So why do we care about the greatest integer function? Because it works really, really good with finding one-sided limits. It says find the one-sided limit of the greatest integer function, and then it shows that little symbol for the greatest integer function as x approaches 0 from the left and from the right. That is, find the limit as x approaches 0 from the left with the negative sign, and of course this shouldn't be just an x there. Here we should have the greatest integer function symbol on there. So there's another little typo that I found. I apologize for that. On both of those, you should have the greatest integer function. So it says find the limit as x approaches 0 from the left of that function, and find the limit as x approaches 0 on the right of that function. Okay? Well, I don't care if you do this graphically. I don't care if you use this with a table. I don't care if you do it analytically. I really want you to think about what this function looks like. Okay, so consider the value x equals 0. Imagine if I put in, well, if I put in 0, I get a 0, right? If I put in any number, here's the x equals 1, here's x equals negative 1, right? Any number between 0 and 1, any number to the right of it would be rounded down. So that would actually be all the way here. Every single one of those numbers would be rounded to 0. Likewise, any number less than it, to the left of it, to the left of 0, like negative 0.1, that would have to be rounded down. And again, by rounding down, we mean go down to the next integer level. The next integer level would be negative 1. So we'd be looking at something like this. All the way from negative 1 to 0, all of those would produce a y value of negative 1. So when we look at this and we say, what's the limit as x approaches 0 from the left of this function? Well, looking from the left of this function, what's my y value every single time? The y value is negative 1. Likewise, if I said what's the limit as x approaches 0 from the right of this function, well, look at it. Come from the right of this function, the y value every single time is 0. So that would be our left-sided limit and our right-sided limit. Notice if I said, what's the limit at that point? What's the limit as x approaches 0? Let me just write this down. This isn't part of the problem, but I want you to think about it. What's the limit as x approaches 0? Here you would say it does not exist. Why does it not exist? Because the limit from the left and the limit from the right aren't the same thing. The graphs don't meet. They don't touch. Okay. Let's go on to theorem 2.10. It says the existence of a limit. Let f be a function and let c and l be real numbers. Let the limit as f of x as x approaches c is L if and only if the limit as x approaches c from the left of f of x equals L and the limit as x approaches c from the right of f of x equals L. That is something that we already know. This is something we already talked about. The left must equal the right, and if the left equals the right, the limit exists. And if the left doesn't equal the right, then the limit does not exist. Likewise, this actually goes the other direction on the top one. If the limit exists, then you know the limit from the left equals the limit from the right. So I'm being a little lazy here. I'm not writing all the words. I'm just telling you that's what it is. If the left and the right meet, that's the limit. And if they don't meet, there is no limit. It's pretty much that simple. Okay? The next one's what I was talking about on the previous problem when we used bracket negative 2 comma 2 bracket. It says a function is continuous on a closed interval, closed A to closed B, the brackets, right? If f is continuous on the open interval AB, which we knew it was continuous on the open interval negative 2 to 2, and if you look at the left endpoint, that A, you have to be continuous as you come to that left endpoint. So as you come from the right to that left endpoint, you have to be continuous. And B, you can include B, the right endpoint, is if as you come from the left of that endpoint. So all I'm doing is I'm thinking about, here's the value A, and here's the value B. We have to come from the right of A, and we have to come to the left, or from the left to B. And that's all that's saying, is it's saying if you come from the right of A, and it's still continuous, meaning the limit exists and the function exists and they're the same, then you can use a bracket. Likewise, if you come from the left of B, the limit exists from the left, right? The function exists and they're the same, then we can put these in brackets. So that's all we're doing on that one.